Okay, class, so today we're going to learn about the ambiguous case, otherwise known as angle, side, side. You all know that this is not a way to prove triangles are congruent, but it could possibly create a triangle. You also can all laugh now while I erase this word off the board. Okay, so if you're given the measure of angle A, which is here, is 30 degrees. Side B is 9, and side A is 3. The information you're given gives you an angle, side, side, triangle. But if you look at the side right here, A, if it's only 3 units long, you'll notice that it doesn't create a triangle. It's too short to create a triangle. So the reason this is called the ambiguous case is because there are 3 different things that can happen. We're not really sure. It depends on the third length of that side, that's swinging side A. So if A is 3, you notice that there are no triangles created. So that is case 1, that we will have no triangles when we're given information with angle, side, side. The other case, let me move this. And let me make A a little bit longer. Okay, what happens if I make A exactly 4.5 units long? How many triangles do we get? So if our A was 3, we got no triangles. If A is 4.5, we get exactly 1 triangle. And what do you think is going to happen if A is longer than 4.5? So let me show you. Let's take A and let's make it longer than 4.5. If I make A 5.5, it actually, if you swing A back and forth, this is first A, and it creates this triangle over here. Notice that triangle is an obtuse triangle because it has an obtuse end. Okay, if you swing side A over here, we create this acute triangle using that same angle and that same side that we used at the beginning. This is still angle, side, side. Now you just have a swinging side that creates 2 different triangles. So this is why angle, side, side doesn't prove it's congruent, because it has 3 different cases. Okay, it can, however, create triangles. It just creates 3 different cases based on this third side length that's swinging, the 5.5, right there. So if you go to your notes pocket, you will see all 3 of those cases and what we have to do to solve them. So the first thing is, if you look here at figure 1, we are given a side, and an angle. So this would give us SSA. I'll spell it backwards now. So if we have SSA, we know it's the ambiguous case, and we need to figure out how many triangles there are. So this is the first triangle that can be created with those, and this is the second triangle that can be created with those measurements. Okay, I want to know, how does this angle A relate to this angle, which we call A prime? It just means like the second A. So I want to know, how do those relate to each other? So, as I always say, somebody sat in a room and did a lot of math, and they figured out finally that if I overlap these triangles, so look at figure 3 here. What they did was they brought figure 1 down, and then they brought figure 2 down, and they made those triangles overlap to create one giant triangle. Okay, let's pretend that that looks pretty there on the bottom. If you notice, this 2 and this 2 are exactly the same, which means these 2 sides are congruent. If you remember from geometry, that is an isosceles triangle, which means those bottom angles are congruent. Okay, I want to know, how does A relate to A prime? Okay, A prime is not this red angle here, but the green one over here, if you notice from figure 2 that I moved down. So I want to know, how do I relate this red angle to this green angle? Well, I have another red angle right here. Okay, I know that this red angle over here plus this green angle here is going to equal 180 degrees. How did I know that? Because they make a straight line on the bottom. Yeah, it's not pretty, but they do make a straight line on the bottom. So if red plus green equals 180, isn't this angle also red? So that means that red angle A, so the measure of angle A plus that green angle, that was called A prime. So the measure of angle A prime is equal to 180 degrees. Okay, we have to remember that because that's how we're going to figure out the two different triangles, or if there are two different triangles that exist. So in our first triangle, we will have an angle. And then to get the angle in the second triangle, we will subtract it from 180 to see if it exists. So in example 1, it says solve the above triangles. The first thing you need to do is identify the ambiguous angle. So if you look at the information that we're given here, which is the same from the picture above, the ambiguous angle was the angle that we had multiple letters for. So we have two A's up here, which means our ambiguous angle is A. Hey guys, it's also the one that we know the side already, but we don't know the angle. So whichever matchup is missing the angle, that's your ambiguous angle. So using this information, is there anything that you feel like you would be able to do using that information to solve? Okay, we have two matchups, and if we have two matchups, we can use law of sines, which is our favorite because it's super easy. So I'm going to go right here, and I'm going to write sine of 20 degrees, because I know that one matches with 2, is equal to sine of, I don't know what degrees, so A degrees over 4. You're going to cross multiply, and when you solve it, make sure you're doing the inverse sign to get sine of A. So when I cross multiply, I do sine 20 times 4 divided by 2, and I get a really small decimal number. So I know that that is sine A equals 0.6840 something something something. Okay, I'm going to go on my calculator and I'm going to put the inverse of that number. So I'm going to do second sine, and then I'm going to go up and get my answer. And I got the measure of angle A is approximately 43 degrees. I like degrees rounded to the nearest whole number because then I can work with them later. So if A, the first A, is 43 degrees, what does that mean you have to do to get the second A? Oh, you just have to subtract from 180. So if you subtract from 180, the second A could possibly be 137 degrees. And now that you have all of this information, you can solve the rest of the triangle by using law of sines. Again, guys, we never have to use law of cosines for this. Okay, it's going to be great. So we're going to do a different matchup this time. Let's still do sine 20 over 2 equals what? How can I get that big C right there? Oh, it's still a triangle. So subtract both of these guys from 180, and you get 117 degrees. So it's going to be sine 117 over little c. When you cross multiply for that one and divide, I don't have to do the inverse this time because I have no letters with sine. So I don't, no inverse this time. I got 5.210 for my side C. Okay, that means that there is one triangle that exists for this problem. So if you remember back to that swinging leg that we had there on that triangle, we know there's one triangle. We don't know if there's another triangle. So let's bring down this 137. that we got before. If you don't remember how we got that 137, we subtracted the 43, the first guy we found, from 180 to get 137. Okay, once I have my 137 over here, I don't have to do law of sines again. By the way, guys, law of sines will never give you an obtuse angle. So that's why you have to do law of sines for the acute angle and then subtract from 180 to get the obtuse angle. So once you get that 137, you can do this matchup right here. So you would do 180 minus 137 minus 20 to get this angle is 23 degrees. Guys, if you get degrees here, that most likely means that there's a second triangle that exists. So I'm going to do law of sines using this. Sine 20 over 2 is equal to sine 23 over little c. And when I cross multiply and solve, I get 2.285 for little c. So for this case of the ambiguous case, we have two triangles that exist, and we solve both triangles. Let's go to the next page and see what happens now. So first thing you need to do is I like to draw a picture. Doesn't matter what kind of triangle you draw. I know measured angle A is 110. I know little a is 30, and I know little b is 20. Okay, this means I have angle, side, side, so I know it's the ambiguous case. I'm not sure how many triangles there are. I have to go find out. So if you don't remember from last time, the first thing you want to do is look at this matchup right here. Okay, I'm going to do law of sines, so sine 110 over 30 is equal to sine b over 20. This will always give you an acute angle because you're using law of sines. And we're going to end up typing the inverse in our calculator. And remember, inverse lives between 90 and negative 90, so you can never get an obtuse angle. This first one will always be acute, and then the second one you get, you can find obtuse by subtracting from 1. So when I cross multiply here, I get sine 110 times 20 divided by 30. So I get sine b equals 0.626 something, something, something. Leave that number in your calculator so you can use it again later. That's not the angle b, that's sine of b. So in your calculator, take the inverse of that. So second sine, go get the answer. And I got approximately 39 degrees for angle b. Remember, round that to the nearest whole number. Now, I need to subtract these from 180 so that I can get angle C, which is 31 degrees. Okay, that is a triangle, still subtract from 180. And again, do law of sines. So sine 39 over 20 is equal to, actually, I don't want to use that one, because I found that 39 and I'm afraid that that might be wrong. So I'm actually going to use the one they gave me. So I'm going to do sine 110 again over 30 is equal to sine C this time, which is 31, over little c. When you cross multiply and solve, you should get 16.443 for little c. Okay, let's go over to case 2. Oh my gosh, I forgot what to do. I think maybe you should go back and look at the front of your notes and see if you know how to find the other ambiguous angle. So if you go back to the front of your notes, remember, the two cases of the ambiguous angle must be supplementary, which means they add to 180. So what was our ambiguous angle? Which one did we find first? Oh, we found B. B was our ambiguous angle, so do 180 minus 39, and you get 141. Already that should be fishy, because 110 plus 141 is way bigger than 180, and you can only have one obtuse angle in a triangle for it to be 180 degrees. So you go to find side C and you subtract from 180, and you're like, okay, I got negative 71 degrees for the angle. That's not possible. So that means that this created exactly one perfect triangle with angle side side. It does not create two. So here, that's an example of one triangle. Now, example 3, what do you think is going to happen if we had two triangles and we had one triangle? Now we're probably going to have, I don't know, let's find out. So let's draw the picture. We have little a, oh that's not little a, that's big A. We have little a is 30. I have little b is 15. Remember, it does not matter where you put your labels. And then I have big B, which is my angle, is 40 degrees. Notice this is angle, side, side. So automatically you should know, wait, that's weird. I have to do the ambiguous case. Oh my gosh, they didn't write it out for me this time. Let's write it out ourselves. So I know that I could possibly have two cases. So I'm going to do case 1, case 2. And I know little a is equal to 30. Little b is equal to 15. I'm missing little c. I know big A, or measure of angle A, is equal to question mark. Measure of angle B is equal to 40. And measure of angle C is equal to question mark. Okay, which one is your ambiguous angle? Look at your matchups. Who do you have right now that you are missing and you can actually find? I can't find any of my C's. I know nothing about them. So I'm going to go to A. That means A is my ambiguous angle. Okay, so I'm going to go ahead and write this as sine A over little a, which is 30, sine 40 over little b, which is 15. When you cross multiply and solve that, you have to do sine 40 times 30 divided by 15, and you get sine A equals 1.28557, and that is not angle A, so you have to click second sign and bring your answer down, and you get error at your calculator, because this number is too big. Sine cannot be bigger than 1. Hey, wait, let's think about our unit circle. Sine lives here. It goes between these two numbers, right? This is 90 degrees, or pi over 2. Remember, that coordinate is 0 to 1. That 1 is sine. Can you go past 1? No. So if this is bigger than 1, you know that that's going to be error. Guys, if you got error for case 1, are you really going to do 180 minus error for case 2? No. Okay, so this means for this case right here in example 3, there are no triangles that exist. And that is everything that can happen with the ambiguous case.